Hello guys, welcome you all to the calculus class. What comes to our mind when we hear the term calculus? Its limits, differentiation, integration, blah blah blah, right? So far we have learned how to deal with the single variable calculus. But now we see the essence of calculus and see the several variable calculus, how can they help us? Okay, I will ask you a basic question. What is the area of circle? It's pi r square, right? If I ask you what is the area of an irregular shape like this, how can you calculate the area? That's where the integrals may help us. We use the concept of taking small strips and integrating to get the whole area. This is what the basic integration mean. We have learned it till now. But what about these 3D structures? I know it's a bit tricky, but using the double integration can save our time a lot. The formula to calculate the three-dimensional structures for the volume of this will look like this. Uh, don't worry, we'll learn more about this in our upcoming videos. Let's move on to the partial derivatives. Just look at this downward parabola. It's in a 3D plane, right? Now what I'm going to do is just cutting down the parabola in x-axis as shown. Now we have got a new curve which is represented by this blue line. When you observe this carefully, drawing a tangent to the new curve, we can only take x as a variable since we have blocked the other y. And since we cannot move any further distance on y-axis, we take it as a constant and taking x as a variable. This is called a partial derivative, dou by dou x. Similarly, by keeping x constant, we can also move y and differentiate with respect to y, and we can name it as the dou by dou y. According to the first principle of derivative, the definition of a partial derivative with respect to x and y can be given like this. Let us solve some of the basic problems of partial derivatives where we are asking to find the partial derivatives with respect to y and x of a given function. Okay, let us start with the first problem. They have given f of x comma y as x square plus xy cube. We have to find the partial derivative with respect to x and with respect to y. Let us solve the partial derivative with respect to x. Dou f by dou x. Remember, while taking with respect to x, we have to take y as a constant, as we have discussed earlier. So with respect to x, derivative of x square is 2x plus, as y is constant, the derivative of x is 1. We can write y cube. In a similar manner, derivative with respect to y equals, as x is constant while we are differentiating with respect to y, so therefore instead of x we have to place 0 plus, as x is a constant and y is variable, x times 3y squared, 3xy squared. This is the first problem. Let's move on to the second problem. F of x comma y equals square root of x square plus y square. As we know, differentiating with respect to x, root x, the derivative is 1 by 2 root x. So therefore 1 upon 2 times square root x square plus y square, and the differentiating of x square plus y square gives 2x plus 0 since the y is constant. So therefore 2x upon 2 root x square plus y square is our answer, and you can cancel out 2 by 2. Differentiating with respect to y equals the same square root x square plus y square, and differentiating x square plus y square, since x is constant, 0 plus d by dx of y square gives 2y. 2y upon 2 times square root x square plus y square. Cancel out 2 by 2. This is the second problem. Moving on to the third problem. F of x comma y equals e power xy log y. E power xy log y. With respect to x, dou f by dou x gives differentiating of e power x is e power x, and differentiation of xy, since y is constant, so therefore differentiation of x is 1 into y. It is y into log y plus, since differentiating with respect to x, log y constant, so therefore 0. We can write 0 here. The formula we have used is differentiation method u v dash u dash v plus v dash u. This is what the formula we have used, differentiation method. And dou f by dou y will get e power xy times differentiation of xy with respect to y will get x times log y plus differentiating log y with respect to y gives 1 by y times e power xy. This is what the problem looks like. Now, moving on to the fourth problem. F of x comma y equals sine square x minus 3y. Differentiating with respect to x, dou f by dou x gives 2 sine of x minus 3y, and differentiation of a sine theta is cos theta, cos of x minus 3y, and differentiation of x minus 3y, since y is constant, derivative of x is 1, so therefore 1. Differentiating with respect to y, 2 sine of x minus 3y, cos of x minus 3y times differentiation of x is x as a variable, it gives 0, and minus 3y gives minus 3. Therefore, we can get minus 6 sine x minus 3y cos x minus 3y as our answer. Now let us see fifth problem. F of x comma y equals tan inverse of y by x. Now let's see the derivative of tan inverse x first of all. The derivative of a tan inverse is 1 upon 1 plus x square, right? Remember, the derivative with respect to x will get 1 upon 1 plus y by x whole square times derivative of y by x. Since y is constant, y times derivative of 1 by x is minus 1 by x squared. So therefore, minus y by x squared upon 1 plus y by x whole square. It is what the derivative. Dou f by dou y with respect to y equals 1 upon 1 plus y by x whole square. Since 1 by x is a constant, 1 by x times derivative of y is 1. So 1. Therefore, 1 by x upon 1 plus y by x whole square. Next, sixth problem. F of x comma y equals to e power minus x sine of x plus y. Now differentiating with respect to x, we can get e power x is e power x, of course. Differentiation of a minus gives minus times sine of x plus y plus differentiating sine of x plus y cos of x plus y times differentiating x plus y. Since y is constant and the derivative of x is 1, we can write into 1 times e power minus x. Okay, dou f upon dou y, what we'll get is, since e power minus x, that is a constant, we can write as 0. 0 multiplied by sine of x plus y gives 0 plus sine of x plus y cos of x plus y times e power minus x. We have used a product rule of differentiation in this formula. I'm sure you will know about this. Next, seventh problem. f of x comma y equals x power y. Look at this carefully. Don't let this problem to confuse you. First of all, derivative with respect to x. Dou f upon dou x as differentiating with respect to x, treating y constant, x power something is x power n, n times x power n minus 1, right? So therefore, y times x power y minus 1. We can confidently write this because y is a constant with respect to x. But while differentiating with respect to x, since x is constant, a constant power variable, a power x, differentiation of a power x, where a is a constant, is once again a power x times log a. Similarly, x is constant here, so x power y times ln x is the answer for this question. Don't put 0 directly over here. It's mistake. And next, eighth problem. F of x comma y equals log x base y. Look at carefully. It is a log x to the base y. We have a property of a logarithm. It's like this. If you have log x base y, you can write it as log x to the base e upon log y to the base c. It's a property of logarithm. We are using it here. Log x to the base y, we are writing it as ln x upon ln y and differentiating. Dou f upon dou x equals log x is 1 by x times log y. I am using u by v formula. U dash v minus uv dash upon v square minus derivative of log y. Since y is constant, it gives us 0 upon log y whole square. Differentiating with respect to y. Since x is constant, it is 0 minus 1 by y. Differentiation of log y is 1 by y times log x ln x upon ln y whole square. Okay. Next problem. Ninth problem. F of x comma y gives integral x to power y j of t dt. Okay, think about the basic differentiation idea, basic difference relation between differentiation and integration. We already know that integration is the reverse process of differentiation. By differentiating an integral, we get the in function. So by differentiating with respect to x, we'll get g of x directly. Why? Because the differentiation of an integral is nothing but a function. It cancels out. Why? Because it is a reverse process. Similarly, dou f upon dou y equals g of y. And finally, the last problem of this class, f of x comma y gives sigma n equals 0 to infinity xy power n, where xy is okay. Okay, let us expand this first. Xy power 0 plus xy power 1 plus xy square plus and so on. Differentiating, I think we can also expand this. 1 plus xy plus x square y square plus x cube y cube plus so on. By differentiating with respect to x, what we'll get is, well, differentiating 1 is 0 plus differentiating with respect to x, since y is a variable, y is a constant and x is a variable. Differentiation of x is a 1, so y plus 2x times y square plus 3x square times y cube plus and so on. Differentiating with respect to y equals x plus 2y x square plus 3y square x cube plus and so on. This is what the partial derivatives, basic problems regarding the partial derivatives. In the next class, we'll see the second order partial derivatives, and we'll also learn the chain rule of partial derivatives, Laplace equations, and so on in the next video.